Okay, today we are going to talk about absolute values. And our goal today is that once we are done with today, that you're going to know how to solve an absolute value equation. Tomorrow it's going to be inequalities. Today we're just going to deal with equations. So we need to review a little bit. What does absolute value, or what are absolute values? Oh my gosh, it's like I paid you. Yes. So absolute value is the distance from zero. That's really the best way to put it. So when you take the absolute value of a number, you're trying to figure out how far is that number from zero. So I teach geometry as well, and we talk about distances. Actually, if you look on the board, there's a distance formula. They just took a test over distance. The distance is always positive. If I drive from here to home or from home to here, the distance, my car is still calculating the distance as a positive distance. So when we are taking the absolute value of numbers, where we need to make sure that it's always equal to a positive. And you'll see here in a second. So here's a couple of equations that technically we could solve, but we're going to be doing a couple of extra little steps when we're solving them. So this equation right here in number 1 says the absolute value, those little bars mean absolute value, of x equals 2. So in words, what this means, and this might seem annoying at first, but I want you to get used to understanding what these words mean. This equation is asking what values of x are a distance, because I liked that Jack used that word. What values of x are a distance of 2 from 0? So that's what these absolute value equations are asking. What value or values of x are a distance, in this case, of 2 from 0? So what is one value of x that would be a distance of 2 from 0? What is a number that is 2 from 0?
2. 0.
2. 2 is 2 from 0. So if here's 0, right here. If I go 1, 2, I hit 2. And negative 2. It's because you go 1, 2. So negative 2 and positive 2 are my two numbers, two values that are a distance of 2 from 0. That's how you've got to think of these. That's why we have a little number line over here to kind of help with you to see it. So that's what you ask yourself for these. So the next one, we have the absolute value of d equals 5. So what you're going to ask yourself in your head, what values of d are a distance of 5 from 0? So if I'm at 0, what numbers would have a distance of 5 from 0? 5. So d would equal 5. So here's 1, 2, 3, 4, 5. What else? And negative 5. 1, 2, 3, 4, 5.
So it's just like
Go ahead. It's just like what?
5, that's just the negative version.
The opposite. Yep. The number and the opposite. Yes. Yes.
Absolute value is always positive.
When you take the absolute, so if I were to put, so here you go. That's a good question. That's a good observation. So if I take this 5 and I substitute it in, if I take the absolute value of 5, what is the absolute value of 5? 5. Okay. So that's me plugging this one in. Now let me plug this in. What's the absolute value of negative 5? 5. So that's why this is whatever value I'm plugging into the bars. So you're right though, Jack, because anything I plug in here, these bars automatically make positive. So you're right. There are two numbers, though, that I can put in these bars and get a positive 5 out. So that's why we have two answers. Does that make sense?
Yep.
Okay. That was a good question. I don't think anyone's ever asked that in all of my years of teaching. They just kind of go with the flow. And I think that will help make more sense. Okay, last one, number 3, that we're going to kind of just chat about here. What values of t are a distance of -10 from 0? So what values of t would be a distance of -10 from 0?
Wait.
Does that make sense though? Does -10 make, when we did these and we counted, right? We counted 1, 2, 3, 4. So can I count to -10? Like if I'm using my counting numbers,
Sure.
can I have a distance of -10?
I don't know.
What do you think? Do you think you can have a distance of -10?
Sure. Because you're going
Will you-
backwards 10.
No, you can't.
You can't.
Why?
Distance is like a length. And how many of you have seen like a ruler or a tape measure?
Never seen a ruler.
I've never seen a ruler go backwards from 10.
Okay, so
or
you've never
backwards from
seen a
0.
ruler go negative. There's no negatives, right?
That's not a ruler.
It's kind of like a ruler.
It's not
A number line is something that you measure on.
Yeah, but
So
number line has negatives.
listen,
Ruler doesn't.
listen.
Negative height.
Yeah, I can.
You cannot have a negative height. You cannot have a negative distance.
That's like count.
So here, so this is kind of like what Jack said. He said, anytime I take the absolute value of something, I've always been told that I need to get a positive number. This is saying here that when you take the absolute value, you get a negative number. So this is an example of no solutions. Because
Wait,
you're,
why would it just be 10?
listen, I just explained it. Listen. It's exactly what Jack just said. He said, I was always told that when you take the absolute value of something, it makes it positive. But this problem right here is saying you take the absolute value and it's negative. So if you have an absolute value equation and the absolute value bars are still on and it's equal to something that's negative, you can't do that because you can't have a distance of -10. It's the same thing like I kind of talked about me driving from home to here and here to home. But if I go from here to home, it's still 30 miles. So that's why my odometer doesn't go backwards. So that's why you can't have a negative distance. So no negative distances.
So that's just always no solution.
If you have your absolute value bars, if the bars are on, because we're going to learn here in a second, we're going to take these bars off. But if the bars are still on and it's equal to a negative number, that is a no solution. Because you're asking somebody to find the distance, a negative distance, and you just can't, that's not possible. Yes.
But you can walk backwards.
How many steps, but how do you measure
You're
that?
still going a certain distance.
But you're still counting. If I go this way, you go 1, 2,
No, I go negative
3.
1.
Yeah,
Yeah.
right.
You start
No,
this.
you-
Ready?
Sit down. Sit down.
-1. No, you skip 0. You count like that.
Okay.
That's how I count.
So you'll see a couple of extra little examples of this to kind of help you to understand and identify when there's no solution or when there's actual solutions. So to solve these absolute value equations, there are some steps that will help you to be successful. Today, my recommendation would always be to keep these steps out to help you out. So number 1, to solve these absolute value equations, the very first thing that you need to do is get the absolute value bars, get the absolute value of x by itself. You're going to use your awesome algebra skills to isolate that. So your main goal first is to get the bars by themselves. Nothing attached to them. You cannot, another little fun fact, these are absolute value bars. These are not parentheses. So you cannot distribute into the absolute value bars. If they were parentheses, then you absolutely could distribute, but you cannot distribute into these. And you're going to see that here in a second. So they're not parentheses, they're bars, which means don't come in. Once your absolute value bars are by themselves, then you get to take the bars off. And this is where it's going to get kind of weird. And create two equations. And we'll talk here in a second about what those two equations look like, which is kind of what we did up top. Like for number 1, it said the absolute value of x equals 2. The bars were by themselves. So once the bars were by themselves, we took them off and created our two equations right here. X equals 2 and x equals negative 2. Once you've created your two equations, then your last step is going to be to solve for the variables. Now today, for the most part, you're going to hear me going over all of the examples. I probably won't let you loose on problems on your own until your assignment because I want to walk through as many examples as possible so that you get a good idea of what to do. Because absolute values are kind of weird. They're not hard, but they're just weird. And they always seem to be a little bit of a struggle every year. So keeping these steps in mind, let's walk through number 1. So number 1, we have the absolute value of x plus 5 equals 11. So if we take a look at our steps, step 1 says to get the absolute value of x by itself. We need to get the bars by themselves. So for number 1, if we have the absolute value of x plus 5 equals 11, the bars are not by themselves on this side of the equal sign on the left side. So we need to get the bars by themselves on the left side of the equal sign by doing what? Perfect. You're going to subtract 5. So you're going to use those same solving skills. Once you subtract 5, we are left with the absolute value of x equals 6. So the bars are by themselves now. And now we can move on to step 2. Step 2 says take the bars off and create your two equations. So when we take the bars off, we do create two equations. And I think I was taught this way, so this is why I do it. I draw a line down with the left and a right-hand side with these absolute values so that I remember that I have to have two answers. So what I'm asking myself is, what values of x have a distance of 6 from 0? So the values of x that have a distance of 6 from 0 are x equals 6, and x could also equal what? Negative 6. Notice the bars are off. Once you have your absolute value bars by themselves, then you can take them off and actually solve your problem. Okay, let's do another one. Because that's it. That's your answer. You're done. Let's take a look at another one. Number 2. 3 absolute value of v minus 7 equals negative 5. So step 1, get the absolute value by itself. So you need to get the bar by themselves. You're going to be super tempted to distribute that 3. You can't though. These are bars. So like the 5th time, these are bars, not parentheses, guys. Don't distribute in. You're going to want to because you just always have, but don't do it. I got to pause there.